This Buick was brought in because the AC does not work at idle. Doesn't overheat or anything, just the AC doesn't work. The issue is it's running about 450. It gets up to 450 on the high side of the AC system, and then that itself disables the system before it builds too much pressure and bad stuff happens. So one of the first things I looked at was the fan, and you can see that the fan is commanded on by the computer now. If you look down there, there is no fan working. So with no fan operation, that absolutely could be the issue. Pressure and temperature directly correlate with each other. If that fan is not running air over the condenser, it will get too hot and therefore build too much pressure. So the next step is to test the fan. What I like to do typically is unplug the fan connector here. Um, I like to just go through. So I'm going to command the fan on. This is key on, engine off now. I heard the relays click, so that seems to be okay. I just want to test here. There's three fan relays. So that's ground, power, and power, and power. So everything voltage wise and ground wise is there for the fan to work. The next thing that I like to do is, before I condemn any electrical component, is I like to actually just um, test it by manually supplying what it needs to work. If I can get this on there. This is just the ground lead here on the alligator clip I'm hooking up. A little bent up. So if I go like this, the fan the fan works when I supply it with what it needs. So the fan has everything voltage and ground wise it needs to work, but it still doesn't work. So the issue is somewhere in the electrical circuit is a wire or a component that's unable to shoot enough voltage to the fan to actually let it operate. Um, the next step from this point would be to pull the relay. I'm going to command this off once just so it's off. Heard the relay click. I actually felt it too. I looked at a wiring diagram and a schematic before this, so I'm just verifying off the diagram on the relay. But basically, what that means is you have, so this is your output here. This is to this fan, the fan connector. This is all the time power supply, and these are computer controlled. So nothing on this one now. I got voltage here. So what happens is basically I believe the computer grounds this terminal, supplies power here, flips a switch, and then this power is able to bridge over to this, and that's what shoots power to the fan. Um, so one thing I like to do from here is I like to just command the fan on. So now you got power there, command it back off. That seems to be working. You got power there, on, you got ground, off, you got power. So that all seems to be working well. From here, what I want to do is I just want to actually load test the wire. By load test, I mean I want to make sure this wire is able to carry enough amperage to power the fan. To do that, I just have a spade cut off of a relay, just so I don't spread any pins or terminals or anything like that, because you'll create more issues if you don't use the proper tool for this. But I like to just push that in so I can still get it back out. Um, I'm going to hook this ground lead to this. So basically, all that I'm doing is I'm adding a ground on this side of the circuit, on this end of the wire here. I'm going into the power feed here, and then from here, all that I'm doing is I'm adding a light bulb in the circuit. And then from all the way on the other end of the light bulb here, I'm actually going to shoot. I have ground on that side, so I'm going to shoot power. If this light bulb lights up, then this circuit is good. There's no issue with this wire. Um, yeah, and that lights up, and it's bright too. So this wire is good itself. Another thing while we're here, I'm going to load test the ground also, make sure that it's a good ground. So, and there, that lights up good. So power and ground, the wiring wise, everything is there for the fan to work, and it can carry enough amperage to operate the fan. So from here, I don't, it's not necessary to test the other two wires with 12 volts, because if you can verify that the high speed is working and can carry a load, and the ground is working to carry a load, and the fan still doesn't work, the other two are irrelevant at that point. It should be working. So what I'm going to do is I'm just going to pull this terminal back out. We had already verified that the computer is able to control the actual relay, and make the switch operate inside to shoot power to the other side of the relay. So what I want to do here is I want to actually load test this all the time voltage supply, because the computer is able to control it. I can hear the relay clicking, so there's no reason to really go in that direction. But from here, if this voltage supply, if this light bulb doesn't light up, then I have to go from the fuse box back to wherever it gets power from here from. If it lights up, then the relay itself is more than likely bad. Yeah, and it lights up. So here, the only thing that could really be causing this is a relay. I'm going to track one down quick. We'll put one in, and then we'll see if it lights up. So I tracked a relay down. The only thing in between everything that we've tested is this. So this is pretty much verified 100% bad. You could test this relay, but at this point it's not necessary. If I put this in, I just want to make sure the fans are commanded off. If I put this in, I'm going to have to reconnect the fan here. So now with that plugged back in, when I hit on, this fan will come on. There it goes. And back off. So the relay the whole time was, when that switch would move over to complete the circuit for the power side of the fan, that relay was not able to put enough current through it to actually operate the fan, even though it had 12 volts at the connector. All right, so now that the relay's in, the fan is working, and if you look at the AC pressures, they're running right where they should be. AC compressor's pump kicks on, it builds temperature or pressure, and then the fan should kick on probably around 300 psi. Then the fans kick on, the pressure decreases, and the AC compressor is able to stay running. So it's fixed.